An object has a velocity given in meters per second and a position also given. What is the average velocity in meters per second from t equals 0 to t equals pi? So you're looking for distance divided by time. And there's two methods. The first would be to use the position equation and find the two distances. We would want x at pi minus x at 0. And these units are going to be in meters, all divided by time of pi minus 0. Those units will be in seconds, and we'll have meters per second. And so that first position will be negative cosine of 2 pi. Cosine of 2 pi is going to be 1. So we've got negative 1 plus time of pi plus 1. We can see the negative 1 and the positive 1 cancel out. So we're left with just pi. Now we'll find the position when time is 0. Well, this is also going to be negative 1. Because cosine of 2 times 0 is cosine of 0 or 1, plus the time of 0 plus 1. So now we have a time of 0. So plugging into this equation up top, we're going to have pi minus 0 all over pi minus 0 for an average rate of change, or an average velocity of 1 meter per second. Our second option is to find the average value. And because the value we're looking for is velocity, we're just looking for average velocity. So that's going to be the integral from 0 to pi of our velocity, 2 sine of 2t plus 1 dt. Well, this is going to give us displacement measured in meters, but I'm going to need 1 over b minus a, and in this case, our b is pi and our a is 0. So we'll need to integrate. The integral of sine is negative cosine, so we'll have negative 2 cosine of 2t, and we'll divide by the derivative of the inner function, which is 2, and the antiderivative of 1 will be plus t. And we'll integrate from 0 to pi, and we'll multiply times 1 over pi minus 0. When we find our antiderivative, we've got negative cosine. When we plug in our limits, we have 1 over pi times negative cosine of 2 pi plus pi minus a negative cosine of 2 times 0 plus 0. And so notice we have negative 1 plus 1. We still have pi over pi, or 1 meters per second. Both methods give the same answer. In this case, the first method was probably easier because you were given the position function. Oftentimes, you're just given the average velocity function. In that case, method 2 would probably be easier.